In this video, we're going to talk about 9.2 objective 1, where we find the x and y components of a vector. They're giving us an example over here at the right, where they say vector A of magnitude 369.8, which is this blue line here, and a direction of theta is 209.03 degrees, which they're showing here. And then they're showing the reference angle here. Because it's in quadrant 3, they subtracted 180 from it to get the reference angle of 29.03 degrees. Has x and y components that are negative 323.3 and negative 179.5, negative for both components because it's in quadrant 3. We could also put that a sub y right here to help us see that right triangle and use our sine and cosine functions to do that. But what they want us to do is they want us to keep the same magnitude of this vector, but they want us to change the angle to be 270 degrees, which is going to put it on the, let me change this up and draw my axes in black like they did. And then let me draw my vector in blue like they did. And that is going to be, well, I'm trying. Give me just a second. All right. Now, here we go. So 270 degrees is going to be here on the negative y-axis. And so that's going to give me a angle here of theta equals 270 degrees. And that means that we're going to have 0 component in the x direction and a negative 369.8. The entire magnitude is going to be going down in the negative y direction. All right, let's go ahead and keep going here. Let's resolve the vector, the indicated figure here. And what we're going to do is we're going to draw a right triangle here with 10 degrees, 10.0 degrees here. And we're going to call this side A. And we have that measurement that A is equal to 786.6. And we're going to call this side A sub Y and this side A sub X. And we're going to use trigonometry to say that because cosine of theta is equal to a sub x over a, that a sub x is going to be equal to a cosine of theta. So a sub x is going to be equal to 786.6 times the cosine of 10.0 degrees. Make sure you're in degree mode in your calculator. 786.6 cosine of 10.0 is going to be a sub x is equal to, and they want us to round to the nearest tenth, so 774.6. Likewise, sine of theta is going to be a sub y over a. So a sub y is going to be equal to a sine of theta. We're just going to keep using these formulas over and over again. I'm not going to rearrange the formula every time for you, but 786.6 times the sine of 10.0 degrees. Again, make sure you are in degree mode. 786.6 sine of 10.0 degrees. We're going to round this to the nearest tenth, and we're going to get 136.6. Let's go ahead now and resolve the vector that's here. And I'm just going to jump to a sub x equals 56.9 cosine of 125.0 degrees. And round to the nearest tenth, we call this negative 32.6, and a sub y is going to be 56.9 sine of 125.0. Again, to the nearest tenth is going to be 46.6. That makes sense. We're in quadrant 2. We should have a negative x and a positive y. We're in quadrant 3, so we expect a negative x component and a negative y component. So a sub x is going to be 6329 cosine of 230.0 degrees. Watch out, we've been rounding to the nearest tenth, but now they want us to round to the nearest integer. So this is going to be negative 4068. And a sub y is going to be 6329 sine of 230.0 degrees. 6329 sine of 230.0. And again, to the nearest integer is negative 4848. Let's keep going here. We're completely horizontal here, so our vertical component is 0, and the horizontal component is going to be 790. Let's draw a diagram here. We have a theta of 68.7 degrees, a force of 16.6 pounds. I'll call that force F. We'll call this F sub y and this F sub x. Both of those are going to be measured in pounds, just like the resultant force was. So the x component is going to be 16.6 cosine of 68.7 degrees. And we want to round to 2 decimal places. This is to get this to 3 significant figures because we had 3 significant figures to start off. So 6.03. And f sub y is going to be 16.6 sine of 68.7 degrees. They're going to tell us to round to 1 decimal place here, again, to get us to 3 significant figures because this is 15.5, 3, and 3 significant digits or significant figures. And these are in pounds of force. All right, let's take a look at this next one here. Solve the given vector into its x component and y component. The given angle theta is measured counterclockwise from the positive x-axis, so 90 degrees means that we have an angle that's completely in the vertical direction here, which means that there's no horizontal component, and this is in the positive y direction, so this is just 90-20 feet per second is the acceleration in that direction. Let's go ahead and feet per second squared, sorry, it's acceleration. And let's look at this last one of an angle of 245.07. It's going to be a little bit down here, like so, and 2.21. We're going to call this a sub x and a sub y, and they're both going to be negative because it's in quadrant 3, and sure I can see that decimal point there. All right, so a sub x is going to be 2.21 millinewtons times the cosine of 245.07, 2.21 cosine of 245.07 is going to give me, and then it wants us to the nearest hundredth, negative 0.93, and a sub y is going to be 2.21 sine of 245.07 and 2.21 sine of 245.07 is negative 2.00 millinewtons. That's it for this video. We will come back next time and talk about 9.2 objective 2. See you for the next video.